Welcome to the deep dive, where we really plunge into stacks of information and try to surface with clarity, insight, and, those amazing aha moments. Today, we're navigating a truly critical piece of aviation safety. It's something you hope you never ever need, but you'd be profoundly grateful for if you do. We're talking about the Emergency Locator Transmitter, the ELT. And this isn't just about the technical stuff, the specs. It's really about understanding a silent guardian, one that has fundamentally changed search and rescue. We're going to unmask how it works, what keeps it ready, and maybe help you think about making the best choices for your own safety in the skies. And hey, before we launch into this really crucial topic, if you're like us, driven by curiosity, eager to understand the world, always seeking that next big insight, well, then you are exactly where you need to be. We are building this incredible community of curious minds. And honestly, your likes, shares, and subscriptions to the All Sorts of podcasts on YouTube are like the fuel beneath our wings. It really keeps us going. Just imagine a universe of knowledge, everything from hidden histories to cutting-edge science waiting to be explored, all distilled into compelling, engaging conversations. Subscribing to the All Sorts podcast on YouTube is your gateway to deeper understanding and hopefully countless aha moments. So come on, join our crew. Like, share, subscribe, help us navigate these new frontiers of knowledge together. And for quick insights, maybe some behind-the-scenes glimpses, find and follow us on X, Instagram, and Threads. And to all of you who have already joined us on this journey, seriously, thank you. Your support propels every single deep dive we make. Okay, let's unpack this. Let's explore the fascinating world of ELTs.
Indeed. And what's truly remarkable about these devices is how a relatively small piece of kit can have such an immediate impact on search and rescue efforts. It's quite something. We'll trace their evolution a bit, dissect the nuances of how they actually activate, and really underscore why staying fully informed about them is just paramount for anyone involved in aviation.
Yeah.
That's from seasoned pilots right through to the avid enthusiast.
Right. So to kick us off, in really simple terms, what exactly is an ELT?
Okay. At its core, an emergency locator transmitter, the ELT, it's basically a compact radio device. Its sole purpose, its entire reason for being, is to spring to action and transmit a distress signal if an aircraft experiences a crash or, a significant impact. It's designed to be the first responder's best friend, really, dramatically speeding up the process for search and rescue teams to locate the aircraft.
So it's like the aircraft's own panic button that presses itself in an emergency. How did these become standard equipment? Was there a specific moment?
Well, historically, the need for rapid location became tragically clear over time. If we step back a bit, these devices actually became a formal requirement in the U.S. It's back when Congress amended the Federal Aviation Act in 1970. That mandated ELT installation on most U.S. civil airplanes. And then the FAA, the Federal Aviation Administration, they implemented this through specific regulations, the Federal Aviation Regulations, or FARs as they're known.
Got it. So the mission is pretty clear. Help rescuers find you fast. But I've definitely heard about something else that complicates things. False alarms. How big of an issue are those, really?
That's a critical point. False alarms are a significant, persistent challenge. A really big one. In fact, they vastly outnumber actual distress situations.
Right.
And an unwarranted ELT signal isn't just, a minor annoyance. It triggers expensive, time-consuming searches. It ties up crucial emergency frequencies. And it can even jam other vital radio comms channels, especially near busy airports. That's a real problem. And these false alerts, they're frequently caused by things like improper installation, maybe a lack of familiarity with how the beacon operates, or even something as relatively common as a hard landing.
Wow. Okay, so it sounds like understanding these devices isn't just for emergencies then. It's also about operational efficiency and, avoiding putting unnecessary strain on those rescue services.
Exactly. Preventing false alarms is a big part of the picture, too.
So if I'm looking at an aircraft or maybe thinking about one, what are the main types of ELTs I might encounter? Are they all basically the same thing?
Oh, not at all. There are primarily two general categories, sort of based on how they're installed and activated. And these usually show up in three main forms. First, you've got the automatic fixed ELT, or AF. This type is, like the name suggests, permanently mounted inside the aircraft structure, and it's designed to activate automatically on impact. Then there's the automatic portable ELT, or AP. Now, these can be removed from the aircraft. The idea is the crew could manually activate it and operate it if the plane is damaged but maybe still somewhat intact, or if they need to evacuate. And finally, we have the survival ELT, or S-type. These are usually found tucked away in life rafts or emergency kits. They're manually activated by survivors after a crash or maybe a ditching in water. Sometimes water immersion itself can trigger them too.
Okay, that makes sense. Different scenarios, different types. For those automatic fixed ones, the AF types, how do they actually know when to activate? Is there some kind of specific trigger?
Right. For the fixed ELTs, the main activation mechanism is inertial. It's all about the G-force. They're engineered very specifically to trigger only with a significant sustained impact. Think about 5 G's of force, or a bit more. And it needs to last for at least 11 milliseconds, which is, a tiny fraction of a second. But it's enough to distinguish a real crash from just turbulence or a bumpy landing. That precision is vital to prevent those false alarms we talked about. However, it's not foolproof. Many inadvertent activations have still happened because these inertial switches can sometimes be triggered by forces from other directions, not just along the aircraft's main forward axis. And for the type SELT, the survival type, especially for overwater use, activation is usually manual or sometimes through water getting into the battery compartment. It doesn't rely on an impact switch at all.
Okay, so the trigger is quite specific, but not perfect. Good to know. This is where the technology seems to have really taken a leap forward, right? The frequencies.
Right.
Let's talk about those. Why are there two main ones, 121.5 and 406 millihertz, and what's the game-changing difference?
Absolutely. This is a huge part of the story. ELTs transmit their distress signals on 2 key frequencies. There's the older 121.5 millihertz, which is mainly for local receivers like other aircraft or ground stations nearby. And then there's the much more modern 406 millihertz. This one is specifically designed for satellite detection. And that 406 millihertz frequency, well, it represents a profound advancement. It's truly a paradigm shift in rescue capabilities.
Okay, paradigm shift. So if I happen to have an older aircraft with just 121.5 millihertz ELT, what does that actually mean for me today? Is it still, effective?
Well, building on that point, the older 121.5 millihertz ELTs are no longer monitored by the International Cosmos satellite system. That change actually happened quite a while ago, back in 2009. So while they might still be legal to operate with in some jurisdictions, depending on the aircraft and regulations, they will not automatically trigger a satellite-based search and rescue response. That's the critical distinction. You're relying purely on someone nearby hearing it.
Wow, okay. No satellite detection. That sounds like a massive difference. So what does that mean for the actual rescue efforts on the ground? How much more effective is this newer frequency?
The impact on location accuracy is just, profound. Night and day, really. An older 121.5 millihertz beacon, if it was picked up, could only provide a general location, maybe accurate to about 12 nautical miles. Now, that sounds okay, but it translates to SAR crews needing to search a massive area, nearly 500 square miles. That's huge. In stark contrast, a 406 millihertz ELT provides satellite-based accuracy to within about 1.8 nautical miles. That shrinks the search area down to roughly 10.8 square miles. Much, much more manageable.
Okay, from 500 square miles down to about 11, that's already incredible.
But wait, it gets even better. Here's where it gets truly transformative. Many, if not most, 406 megahertz ELTs can actually encode additional information into their digital signal. Things like the aircraft's precise GPS position, if it's connected to the aircraft's GPS. This capability refines the location accuracy down to an astonishing 110 yards. It's like the size of a football field or two, maybe 7 or 8 acres. This allows SAR crews to basically proceed directly to the site, saving absolutely invaluable time. Minutes count in these situations. So even though having GPS connected isn't strictly required for a 406 megahertz ELT to work via satellite, its integration offers just enormous, potentially life-saving advantages. And this is precisely why 406 megahertz has become the international standard. It's championed by ICO, the International Civil Aviation Organization, and many countries now mandate its use. Canada, for instance, actually requires ELTs to transmit simultaneously on both 406 megahertz for the satellites and 121.5 megahertz for local homing.
Right, best of both worlds there. Okay, the 406 megahertz difference is clearly massive. So, moving beyond the device itself, you mentioned installation earlier. It sounds like getting that right is absolutely crucial. Are there specific guidelines or maybe common pitfalls people should avoid?
Oh, it is absolutely paramount. You can have the best ELT in the world, but if it's not installed correctly, it might not work when you need it. An automatic fixed type ELT, the AF type, needs to be attached directly to the airframe or some other really robust structural component. It absolutely must be free and clear of any loose cables, control pulleys, or baggage that might shift around. Attaching them to, say, thin cabin partitions, flimsy panels, or using flexible materials like Velcro that's completely unsatisfactory. Just asking for trouble. Why? Because, vibrations could exceed the impact switch's lower limits, triggering those false alarms we hate. Or, even worse, the equipment could just detach in a crash, get damaged, and be rendered completely useless.
Right, so secure mounting is key. What about the antenna? You mentioned that briefly too.
Equally vital, the antenna placement and cabling are critical. Antenna cables must be properly secured to the airframe to prevent chafing or damage. And the antenna itself. Ideally, it should be positioned as far aft, as far back in the aircraft as is practical. It needs to be fully extended and in a vertical orientation when the aircraft is in normal flight attitude. It also needs a clear view to the outside, ideally through a window or perhaps a non-metallic section of the fuselage. At least 12 inches of its length should be exposed.
Okay. And connecting back to those false alarms we keep mentioning, how does the installation, particularly the antenna placement, play into preventing those unintended activations?
Yeah, that brings up another crucial point about interference. Unintended activations aren't just from bumps. They can actually stem from the ELT's own design sometimes. Maybe it's susceptibility to radio frequency interference or RF interference. It can even be triggered by the aircraft's own communication transmitters if the ELT antenna is positioned too close to, say, a VHF comm antenna. So the strong recommendation, is that the ELT antenna should be at least 30 inches away from other VHF antennas. And again, placing it as far aft as practicable helps minimize the chance of it disrupting normal communication and navigation systems, or vice versa.
Makes sense. Keep the antenna separated. So who ultimately shoulders the responsibility here? For preventing false alerts, ensuring proper installation, is it the mechanic, the pilot?
It's really a shared responsibility. All aircraft operators and maintenance personnel have a role to play. Pilots, for instance, should really make it a routine practice, part of their shutdown checklist, to briefly tune their VHF receiver to 121.5 MHz before shutting down the engine. Just listen carefully for any ELT activation sweep. These activations can happen after particularly hard landings or even during aerobatics sometimes. If an activation is detected, the ELT should be immediately shut off. There's usually a switch on the unit or in the cockpit. And crucially, the nearest FAA tower or flight service facility must be notified right away. Tell them it was accidental. And by the way, all such incidents, even accidental ones that are caught quickly, they must also be reported to the FAA for their service difficulty program. It helps track potential issues with certain models or installations.
Right, a collective responsibility for keeping the airwaves clear and the equipment ready. Okay, so given how critical these devices are, sitting there waiting, what actually keeps them powered and ready? And what does maintenance truly involve for an ELT, especially when we talk about its power source, the battery?
The battery is, well, it's absolutely the heart of the ELT's operation. No battery, no signal. Manufacturers are required by regulation to clearly mark the battery's expiration date on the outside of the ELT. This date is usually based on 50% of its calculated useful life, or, if it's a rechargeable type, 50% of its useful charge life. Batteries must be replaced by this date, or they also have to be replaced immediately if the ELT has been used in an emergency for 1 cumulative hour or more, even if the expiration date hasn't been reached. Battery life typically ranges maybe 1 to 5 years, depending on the type and manufacturer, but many common ones require replacement every 5 years, or after that 1 hour of activation. And importantly, the date stamped on the new replacement battery then becomes the new expiration date that needs to be marked on the ELT itself.
Okay, so strict rules on battery replacement timing. What about other maintenance, beyond just the battery swap?
Yeah, beyond just the battery life, regular maintenance checks are really critical. Ideally, these should be done during the aircraft's annual inspection, or maybe more frequently if the manufacturer specifies it. These checks are designed to proactively identify potential issues, things like battery terminal corrosion, which can be a big problem, physical damage to the antenna, maybe loose connections, or problems with the internal wiring or the mounting.
That makes sense. But you mentioned complexity earlier. The battery replacement itself, it sounds like it might not always be straightforward. Can, like, any pilot just swap out an ELT battery?
Not always, no. It depends quite a bit on the type of ELT and how it's installed. For portable ELTs, the AP or S types, that are designed to be easily accessible, pilots can often perform the battery replacement themselves. It's often considered preventive maintenance under the regulations. However, those automatic fixed ELT installations, the AF types, they're frequently much more complex. They're often permanently mounted in fairly remote, hard-to-reach areas of the aircraft structure, sometimes annoyingly close to things like flight control cables or other vital components. Access can be really tricky. In these cases, battery replacement almost always requires a certificated A&P mechanic or a specialized avionics repair station. It's not usually a pilot task.
Okay, accessibility is key there. Now, you mentioned battery corrosion just now, and earlier you touched on lithium batteries. What's the hidden danger there? Is it just about stopping it from working?
It's a bit more insidious than just not working. While modern lithium batteries are generally very reliable and offer great power density, some older designs, particularly lithium sulfur dioxide LiSO2 batteries, well, they had a history of sometimes violent venting or even explosions in rare cases. This led to significant industry efforts and new TSO standards for safer battery chemistry and construction. But even newer FAA-approved TSO batteries can still sometimes emit sulfurous gases, SO2, especially near the end of their life or if they overheat. Now, the problem is, when these gases combine with even tiny amounts of humidity inside the ELT casing, they can form highly corrosive sulfuric acid H2SO3. This unseen internal corrosion process can cause all sorts of problems. Intermittent connections, those dreaded inadvertent activations, internal battery shorting, and even malfunctions of the critical inertia switch. And it's a recurrent problem that can sometimes surface weeks or even months after a battery replacement if corrosion wasn't spotted or cleaned up properly. So for ELTs currently using lithium power, especially older models, it's highly advised against just retrofitting any old lithium battery unless you can be sure it won't emit these harmful gases. And really, any battery replacement, regardless of type, should always be preceded by a thorough inspection for any signs of existing corrosion inside the unit.
Wow, corrosive acid inside the rescue device. That's not ideal. So, boiling all this down, what does this mean for someone trying to ensure their ELT is truly ready and reliable? What's the practical takeaway from all this potential complexity?
The key takeaway, I think, is this. Because the ELT is fundamentally a passive device, it just sits there silently, hopefully never needed, until maybe disaster strikes. Its actual operational status is kind of unknown day to day. You don't know if it's working until you need it or you test it. Therefore, during inspections, it's absolutely essential to check more than just the battery date. You need to verify at least the impact switch operation somehow and the actual transmitter output. Does it transmit a signal? Now, testing. Testing needs to be done carefully to avoid false alarms. Ideally, it should be conducted in a shielded environment, like a screen room or a metal enclosure, to limit the signal radiation. If that's not possible, tests should only be performed within the first 5 minutes after any hour UTC. That's the internationally agreed testing window. And even then, you should only allow maybe 3 brief sweeps of the audio modulation while monitoring it on a VHF receiver tuned to 121.5 megahertz. Keep it short. Any testing outside that specific 5-minute window must be carefully coordinated in advance with the nearest FAA tower or flight service station to make sure they know it's a test and don't launch a rescue mission.
Right. Test carefully, test briefly, and test at the right time.
Got it. Okay, we spent a lot of time focused squarely on ELTs, which makes sense, but there's another device that often pops up in these safety conversations. The Personal Locator Beacon, or PLB. What's the core difference between these two? And, is one inherently better than the other? How do you decide?
That's an excellent question and definitely a common point of confusion for pilots and aircraft owners. While both ELTs and PLBs are ultimately designed to do the same thing, help search and rescue services find you quickly after an incident, their fundamental differences really lie in their portability and, most crucially, their method of activation. As we've discussed, an ELT is an integral component. It's permanently fitted to the aircraft, and it's specifically designed to activate automatically upon a significant impact. That automatic activation is just vital in scenarios where manual activation simply might not be possible, like a sudden severe crash where the occupants might be incapacitated.
Okay, ELT is fixed, automatic. So the PLB, the Personal Locator Beacon, however, is designed for mobile, personal use. It's not permanently installed in the aircraft. You carry it on your person, maybe in a flight bag or a survival vest. And the key distinction here, the really critical one, is that a PLB must be activated manually to start transmitting its distress signal. You have to physically turn it on.
Manually activated. Okay, so what does that mean for real-world safety scenarios? It sounds like relying on manual activation could be a pretty significant hurdle in a real emergency.
It absolutely is. It's a critical point to consider. Think about it. If there's a crash and the pilot or passengers are maybe unfamiliar with how to operate the PLB under stress, or worse, they're physically injured and unable to reach it or activate it, well then no alert signals will be transmitted, nothing goes out. Experience and accident investigations unfortunately show that in the vast majority of serious accidents, pilots and occupants are often unable to perform actions like manually activating a beacon. So while some regulations, like EASA's rules in Europe for light aircraft, might allow PLBs to be carried instead of ELTs on certain small aircraft, typically 6 seats or less. A PLB is generally considered by safety experts to be optional, maybe low-cost ancillary equipment. It's good to have as a backup, perhaps, but it crucially lacks that advantage of automatic activation that an ELT provides. So choosing the right device, or maybe having both, really depends on your aircraft's specific operational environment, the regions you fly in remote areas versus populated, and ultimately your personal assessment of the risks involved. Many would argue the automatic ELT is the primary safety net.
Right. The automatic feature seems like the key differentiator for the ELT in a sudden crash scenario. Okay, so let's say you've got the right ELT, maybe a 406 megahertz one. It's installed correctly by a professional. You're keeping up with the battery and maintenance. What's the final, absolutely non-negotiable step to ensure this whole system actually works and helps rescuers if needed?
Registration. Simple as that. Registration. This isn't just, some bureaucratic hurdle or red tape. It is a critical, potentially life-saving requirement for all COSPA-SARSAT 406 megahertz emergency beacons. That includes ELTs, PLBs, and even EPIRBs on boats. COSPA-SARSAT, just to remind everyone, is that international satellite system specifically dedicated to picking up these distress alerts. They are the global network listening for your beacon.
And why is the registration so critical? What does that information actually do?
Well, the information you provide during registration is precisely what search and rescue agencies like the U.S. Coast Guard, the U.S. Air Force Rescue Coordination Center use to, first, validate the alert, and then figure out who and what they're looking for and how to contact you or your emergency contacts. Accurate, up-to-date registration information is also vital for conserving those precious SAR resources. How? Because many inadvertent activations, those false alarms, can often be resolved very quickly with just a simple phone call if the beacon is properly registered. They call the number, you say, oops, sorry, bumped it, and the search is called off before assets are even launched. Now, failure to register, or maybe failure to re-register, which is required every 2 years in the U.S., even if no information has changed, or failing to update the registry if you sell the aircraft or change your contact info. That can lead to penalties, maybe fines under federal law, but much more importantly, outdated or missing registration information can significantly delay a rescue response in a genuine emergency. They get the signal, but they don't know who it belongs to, what kind of aircraft it is, or who to call to verify.
That wastes critical time.
Okay, delays are the last thing you want. What kind of detailed information are they actually looking for on that registration form? Is it complicated?
It's quite comprehensive, yes, but it's all necessary information by design. It typically asks for the beacon's unique 15 or sometimes 23-character hexadecimal ID. That's the beacon's electronic serial number, basically. You'll also provide the manufacturer and model. That you provide detailed owner or operator information, your name, all relevant phone numbers, home, work, cellular mailing address, your email address. For the aircraft itself, you'll list its registration number, the N number or tail number, its primary usage like private, commercial, government, its types of single-engine, multi-engine, helicopter, etc. Also the aircraft manufacturer, model, its primary color scheme, which helps SAR spot it, seating capacity, what kind of radio equipment is normally on board, any specific survival equipment carried, like a life raft, and its principal home airport. And critically, you must provide emergency contact information for at least one person, preferably 2 or 3, other than yourself. Someone they can reach 24/7 who knows your plans or can verify if you might actually be in trouble.
Wow, that is comprehensive. But you can see why every piece of that puzzle would be incredibly helpful for rescuers trying to figure out what's going on.
Exactly. Every detail helps paint a picture and speeds up the response.
So let's shift gears and imagine the unthinkable does happen and ELT activates in a real emergency. What are the immediate steps taken by search and rescue? And how can other pilots who might be flying nearby actually assist in pinpointing that location?
Right. Well, the primary search and rescue responsibility for downed aircraft in the U.S. falls to specialized agencies, primarily the U.S. Air Force Rescue Coordination Center, AFRCC, for inland searches, and the U.S. Coast Guard for maritime incidents. They often coordinate closely with and task assets from the Civil Air Patrol, CAP, for air searches. Now, the FAA also strongly recommends it's in the Aeronautical Information Manual, the AIM, that all pilots monitor the emergency frequency 121.5 millihertz with any available additional receiver if they have one. This does 2 things. It provides a vital listening network, potentially picking up signals the satellites or ground stations might miss initially. And as we discussed, it also serves as that crucial check for pilots to ensure their own ELT hasn't inadvertently activated without them knowing.
Good point. So if I'm a pilot and I do hear an ELT signal on 121.5, what's the proper procedure? What should I do?
Okay, if you hear that distinctive ELT sweep, whoop, 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 the first step is to immediately notify the nearest FAA ground facility. That could be air traffic control if you're talking to them, or a flight service station. You should tell them your precise position, your altitude, when you first heard the signal, and if possible, when or where the signal seems strongest, or when you lost it. ATC or flight service might then ask you to do a few things to help them get a better fix. They might ask you to activate your transponder's ident feature, or maybe climb to a higher altitude to improve line-of-sight reception for their direction-finding equipment on the ground.
Okay, report it clearly, provide position details, and follow ATC instructions. Makes sense. Now, once a dedicated search aircraft, maybe from the Civil Air Patrol, is actively trying to pinpoint that ELT signal, what are the common techniques or procedures they use to actually home in on it?
Yeah, search aircraft crews are highly trained and use well-established systematic procedures to find the source of that 121.5 millihertz homing signal, which most 4 of its ELTs also transmit. One highly effective method is often called the build and fade using signal strength meter, or sometimes just oral null. Essentially, you fly a straight course and you watch a signal strength meter, or just listen carefully, to see if the ELT signal strength increases, builds, or decreases, fades. If it starts to fade, you know you're flying away from it, so you make a 180-degree turn. You keep flying towards the increasing signal until you pass the point of maximum strength. That point of max signal indicates the ELT is now approximately 90 degrees off your wingtip, either to the right or left. You then make a sharp 90-degree turn towards the signal to confirm your direction and continue homing in.
Okay, kind of like playing hot and cold with the radio signal.
Exactly like that, but a bit more systematic. Another common method, especially useful maybe for ELTs mounted on or near the wing of aircraft with metal wings, is called the wing shadow method. With this, the search aircraft starts a precise, steep-banked 360-degree turn. As the aircraft turns, its own wing will momentarily block the direct path between the ELT signal and the receiving antenna. This causes the signal to suddenly weaken or even be lost entirely for a moment. It falls into the radio shadow of the wing. The point in the turn where this happens helps the crew determine the general direction from which the signal is coming. And there's also a variation called build and fade using squelch. This works similarly to the signal strength meter method, but uses the receiver's squelch control knob. You adjust the squelch so you can barely hear the signal, then you listen for it to either break through the squelch more clearly, build, or disappear entirely, fade as you fly, using that instead of a meter. These methods, while they might sound a little basic, are incredibly effective in the hands of trained SAR crews for pinpointing that 121.5 megahertz homing signal, especially once the 406 signal has gotten them into the general area.
Fascinating. Real detective work using radio waves. Hashtag outro. Wow. What an absolutely incredible deep dive into emergency locator transmitters. Seriously.
Yeah.
From their regulatory beginnings at critical shift to 406 megahertz we talked about, and all those meticulous, crucial details of installation and maintenance, it's overwhelmingly clear that these devices are so much more than just another piece of equipment bolted onto an airplane. They are truly, fundamentally a lifeline. They really do bridge that gap between uncertainty, maybe being lost and alone, and rescue. They offer tangible hope in what could be the direst of circumstances.
Indeed. They really do. And I think the journey through ELTs, all these details, it really underscores a fundamental principle, doesn't it? Knowledge is most valuable when it's actually understood and then properly applied. Staying informed about critical safety systems like these isn't just about, ticking a regulatory box or compliance. It's truly about active preparedness. It's about enhancing your own awareness and ultimately significantly increasing the chances of survival for everyone who takes to the air. Which perhaps raises an important question for you, our curious listener, to ponder. How will you ensure your own understanding of vital safety systems, maybe beyond just ELTs, continues to evolve? What more will you choose to explore next?
That is a powerful thought to end on. And if you found value in this deep dive today, if it sparked a new understanding or maybe gave you one of those aha moments we love, then just imagine the insights waiting for you across the whole universe of topics we explore here. Please join our growing crew of curious minds. The All Sorts podcast on YouTube is really your gateway to discovery. Every episode is an opportunity to learn something new, something fascinating. So please like, share, subscribe, help us navigate these new frontiers of knowledge together. For those quick insights, maybe behind the scenes stuff, follow us on X, Instagram, and Threads. And once again, to our loyal listeners who've already subscribed, thank you. Thank you for being the wind beneath our wings. You genuinely propel us forward into every single new deep dive we undertake. Until next time, keep exploring, keep learning, and please, stay well informed.